Hello math students, today we're doing 6.3 more sine language, so looking at our sine function. Really this stands for sine function, right? So Clarita's helping Carlos calculate the height of different locations around the Ferris wheel. They notice h of t is 30 plus 25 sine theta and gives them the correct angles for 0 through 90. But they need since my triangle only works for acute angles. So we need to make notes and have observed about this new way of defining sine as to be programmed into a calculator. For some angles, calculator gives me positive angle and some gives me negative. Without a calculator, there's 5 angles of rotation where they are positive. What we have to first understand is our unit circle. So our unit circle is just a circle on the coordinate grid, x, y. We have a circle here where my radius is 1. Okay? Each coordinate has an xy coordinate. And if we look at the triangle, look at this theta angle, sine is going to be the y coordinate. Okay? So I know sine of my theta is y over 1. Sine of theta equals y over 1. So the sine of theta are just y values. So if we look at my unit circle, we could list any value between 0 degrees, any value, theta we use for angles between 0 and 180. Because if we look at a circle, 0 starts down over here, 180 starts over here, this is 90, this is 270. So if you want any negative, we want any number between 180 and 360. Any between. So it says 5, but I gave you a better answer than 5 because we know it has to be all values between 0 and 180 for positive because that's above the x-axis. Negative below is between 180 and 360. All right. Sometimes we can't even draw a triangle for certain positions on the Ferris wheel. What are those? So we're going to list all the possible positions where you can't draw a triangle. And that'll be at 0 degrees, 90 degrees, 180, 270, and 360. Well, if our radius is just 1 on a unit circle, 0 degrees has a y value of 0. 180, y value of 0. 360, y value of 0. 90, we go straight up 1, so positive 1. 270, we go straight down, minus 1, so negative 1. Again, all I'm using is this unit circle, this base definition of unit circle. From there, Carlos says, and because of symmetry of a circle, some angle of rotation should have same values and whatnot. So without using calculator, name values. So again, if I draw my unit circle, oops, that's not exactly right. Closer, the radius is 1. So the degree that's here should be roughly the degree there. So if I could say 60 degrees and 120, we already found 0 and 180. I could do 45 degrees, 45 plus 90, right, because we're making these angles here. So 45 plus 90, 135 degrees. I could do 30 and 150. Let's think of another one. Let's do 75 degrees. 180 minus 75, that'd be 105 degrees. Okay, so there's a list there. Right, and we go around the circle more than once and gives us the same values. So multiple angles of the same values. So without using a calculator, find 5 multiple sets. So all we're going to do is the angle and angle plus 360. Because an angle plus 360 gives us all the way around. So 10 degrees and 370 degrees. Right, 20 degrees and 380, 0 and 360, 50 degrees and 710, let's go 100 degrees and 460 degrees. Carlos says, so big, how big can an angle of rotation be, or how small? So the answer really is we could be between negative infinity to infinity. because we could always keep going in circles forever, but clockwise is positive, so if we go in the positive direction over and over again, or if we go clockwise, we go negative. Sorry, counterclockwise. Yikes. Let me get my eraser. I apologize. If we go against the clock, if we go this direction, that's positive. So counterclockwise is positive, and clockwise is negative. All right. And while we're asking these questions, I'm wondering how small the value of sine can be as the angle of rotation gets larger. Value calculator will be the answer to this question. So the question is, sorry, 1 second. How do you write it? How small and how big? Well, if we look at the unit circle, radius 1, so we go up, so sine of theta could be between 1 and -1. Because our unit circle, we go all the way up to 1, all the way down to -1. This is all on the unit circle, And again, if you didn't look at the lesson notes first, a unit circle is a circle with radius 1 and center 0, 0. So the origin is the center and 1 is the radius. Well, whatever the calculator is doing, at least it's consistent with the right triangle's definition of sine as a ratio of opposite side of hypotenuse between 0 and 90. So now we're going to look at angular rotation. So we defined some angles of rotation as a ratio defined and isn't a part of a right triangle. Basically, we begin with radius r, whose center is located at the rectangular grid. An angle of rotation is standard position by placing its vertex at the origin. The ray is the positive x-axis. The terminal ray is where the theta is. Counterclockwise from the origin. Clockwise is negative. Let the ordered pair xy represent the point on the ray and on the circle. In this diagram, theta is between 0 and 90. Therefore, we're in quadrant 1. Has been drawn in quadrant 1, similar to the right triangle of the Ferris wheel. So if we draw this triangle, excuse me, we want to find sine of theta. Sorry, when we know my radius is r, my y value is y, my x value is x, so the sine has to be the opposite, or y, over the hypotenuse r, right? Here's the hypotenuse, here's the opposite, here's the adjacent of theta. We use this definition for any angle rotation, so let's try a specific point. So for instance, they want us to consider the point -3, 4 at the circle x squared, y squared. So remember, the equation of a circle is x squared plus y squared equals r squared. So in this case, your radius squared is 25, so my radius has to be 5. Again, we're dealing with positive, so square root of 25 is positive 5. So we're going to draw a circle with radius 5. And I know -3, positive 4 is a coordinate on this circle. So there's my circle, give or take. So here's the point, -3, 4. So there's my ray there, and there is theta, okay? So I drew that. So what value of sine would be the definition? So here's my right triangle. The radius is 5. This point is -3, 4. So here's -3, here's 4. So the sine of theta has to be opposite 4 over 5, which as a decimal is 0.8. Okay, what is the measure of the angle of rotation, and how do we determine the size of the angle? Well, I know this angle, so I have to do the sine inverse of 4/5. That tells me this theta, or the theta with that angle. So sine inverse of 4/5 gives me 53.1 degrees. 13 degrees, so that's this angle right here. Since these form a line, I know that theta is just 180 minus 53.13. So 180 minus 53.13. And I get 126.87. So theta is 126.87 degrees. Okay, and if I put it into a calculator, is the sine of 126.87 degrees. That should be the same as 4/5, which would equal about 0.8. And let's double check that. In my calculator, sine of 126.87 gives me 0.79999, which is about 0.8. So I'm correct. Yes. Okay, we're going to do the same thing for 10. So my radius squared is 10. So my radius is the square root of 10. So if I draw a circle, square root of 10, because I'm drawing a circle, I need rough units. So that's about 3.16. So 3.16, 3.16, 3.16, 3.16. And I know -1, -3 is a coordinate. So my circle looks something like that. So now I know I have the coordinate -1, -3. My ray looks like this, and that's my angle theta. Okay, so I did that. What is the sine? Sine of theta should be the same. We're looking at this triangle right here. Sorry, we're looking at that triangle right here. So that's over -1 down -3. So our sine of theta should be -3 over square root of 10. We never want to write with a radical in the denominator, so I multiply by square root of 10 over square root of 10. So I get -3 square root of 10 over 10, which my calculator tells me that -3 second square root of 10 divided by 10 is -0.95, roughly. So what does the angle measure? So this angle measure will be sine inverse of -3 square root of 10 over 10, but we're going to make it positive, so we're going to do the absolute value. So we're going to do the sine inverse of -3 square root of 10 divided by 10, and I get negative, or absolute value multiplied by -1, we get 71.57 degrees. That's this angle, so I'm going to add that to 180, and my total angle, or my theta, therefore is 251.57 degrees. So is this the same? So is the sine of 251.57 equal to -3 square root of 10 over 10, which is about -0.95. If I do sine of 251.57, we indeed get -0.948, which rounds to 0.95, so that is true. So all right, so again, we're still using our right triangle trigonometry in these circles, but when we talk about the angle, we have to know to either add it or subtract it from 180, depending on where it's at on the circle. Thank you for watching this lesson video.